To solve this radical equation, we first need to isolate the square root by adding 4 to both sides. Once the square root is isolated, we can square both sides of the equation, leaving x by itself. 9 squared equals 81. Now let's check our answer. In the original equation, plug in 81 for x, and see if it results in a true statement. The square root of 81 is 9, and 9 minus 4 equals 5. Therefore, 81 is a correct solution. This equation already has the square root isolated, so square both sides to remove the radical symbol. This gives us 5x plus 1 equals 36. Next, undo the addition by subtracting 1 from both sides, leaving 5x equals 35. Further isolate x by dividing both sides by 5, resulting in x equals 7. Now let's check if this is a correct solution. In the original equation, substitute 7 for x. Multiplying 5 by 7 gives 35. Then adding 1 gives the square root of 36, which equals 6. Therefore, x equals 7 is the correct solution. To solve this equation, we square both sides, giving us x squared equals 2x plus 3. We now have a quadratic equation. Let's write it in standard form by moving every term to one side and setting it equal to 0. Remember, when you move a term to the other side, you have to change its sign to its opposite. Let's factor it into binomials. Find factors of -3 that add up to -2. -3 and 1 are factors of -3 that add up to -2. Now use the zero product property to solve for x. Either x minus 3 equals 0 or x plus 1 equals 0. This gives us x equals 3 or x equals -1. Let's check to see if both are correct solutions. Write the original equation and plug in 3 for x. Simplify the right side. 2 times 3 equals 6. Then add 3, which gives us the square root of 9, and that equals 3. Therefore, 3 is a correct solution. Let's check -1. Plugging in -1 for x and simplifying the right side of the equation, we get the square root of -2 plus 3, which equals the square root of 1, and that equals 1. Since -1 does not equal 1, -1 is not a correct solution. This is called an extraneous solution, which occurs when squaring both sides of the equation introduces a false solution. Therefore, the only solution is x equals 3.